Imagine a high-stakes vendor negotiation. But there are absolutely no humans in the room.
None at all?
Right. There are no handshakes, no late-night phone calls. It's just two autonomous AI agents.
Just fighting it out over supply chain margins.
Exactly. Reading these incredibly complex contracts and executing a final agreement in, literally microseconds.
It sounds wild, but
But that isn't science fiction anymore. That is the reality of enterprise architecture right now, here in Q4 2026.
yeah, it really is.
I mean, in just 2 short years, enterprise adoption of fully autonomous AI agents has skyrocketed. It went from a mere 8% in 2024 to 45% today.
Which is just a massive leap.
It's unprecedented. And to be incredibly clear for everyone listening, we are not talking about those early, slightly clunky chatbots.
What, the ones that just summarized an email or answered basic customer support questions?
Yeah, exactly. We are talking about autonomous end-to-end engines, systems that execute incredibly complex workflows without ever asking a human for permission.
It's a fundamental shift in how businesses operate. I mean, for the European business leaders, the CTOs, and the developers tuning into this deep dive,
We are at a critical moment.
we really are.
Yeah.
We're sitting at an absolute make-or-break inflection point. Because March 2026 has completely altered the playing field.
Oh, absolutely.
If you look at Eindhoven, for instance, which is effectively Europe's innovation ground zero, right? They're pouring 2.1 billion euros into annual R&D.
That's a staggering amount of money.
It is. And we are seeing this incredible tension playing out there in real time. Because on one hand, enterprise demand for what we call multi-agent orchestration.
Yeah, we're going to dig deep into that term.
Right. That demand has surged by 340%. Because intelligence is very quickly becoming a cheaper commodity than human labor.
And obviously, companies want to capitalize on that margin.
Exactly. But on the other hand, you have Phase 1 of the EUA I Act. And that went into full effect this past January.
Yeah.
So you have this massive collision. There's this desperate push for totally autonomous scale, and it is slamming right into mandatory, incredibly strict legal governance.
Which basically means you can't just, move fast and break things anymore.
No, not at all.
If you break things under the EUA I Act, you are facing existential consequences.
Company-ending consequences, really.
Yeah. So the mission for today's deep dive is to unpack the intelligence we've gathered from AetherLink.
They're a Dutch AI consulting firm.
Right. And we're using their insights to figure out how organizations are actually threading this needle. We want to break down how these multi-agent architectures work under the hood.
And how they're proving the financial ROI.
Exactly. And most importantly, how they are turning regulatory compliance from, a massive bottleneck into an actual competitive moat.
To really grasp the magnitude of this, I think we have to stop thinking about AI as a single omnipotent brain.
Right. That's the old way of looking at it.
Yeah, the paradigm has completely shifted away from the solo agent.
Huh.
I mean, a single large language model, no matter how vast its parameter count is.
That's just too brittle.
Exactly. It's too brittle for complex enterprise-grade execution. Because you ask one single model to retrieve data and then analyze it and format it and execute a transaction.
Just breaks down.
Its context window gets totally overwhelmed. It starts to lose track of the original instructions, or even worse, it hallucinates.
Which you absolutely cannot have in an enterprise environment.
No. So the transformation we are seeing, and really the reason demand is up 340%, is because of multi-agent orchestration.
Right.
This is where you actually divide the cognitive load across multiple highly specialized models.
Let's try to translate that into how software is actually built today, just for the developers and architects listening.
Sure.
It's essentially the AI equivalent of moving from a massive, unwieldy, monolithic application.
Yeah, to a microservices architecture.
Exactly. Instead of one giant block of code trying to do everything, you break the tasks down into independent, highly focused services that just communicate with each other.
That is the perfect mental model.
I like to think of it kind of like a restaurant kitchen.
Oh, I like that. Go on.
So you've got your supervisor agent, right? That's the executive chef. The chef is taking the orders, reading the tickets, but they aren't actually cooking everything.
Right. They're routing the work.
Exactly. They route the subtasks to the domain agents, and the domain agents are your specialized line cooks. You've got one on the grill, one doing pastry, one doing prep.
Yeah.
And then you have your tool agents, which are basically the runners. They're the ones actually running to the fridge, fetching the raw ingredients, which in this case are ERPs or APIs, and bringing them back to the cooks.
That is exactly how it works. And the performance data actually backs up why this kitchen hierarchy, this architectural shift, is so critical.
What does the data say?
Well, there was a 2025 Deloitte study that tracked enterprise deployments. They found that multi-agent systems achieved 2.8 times faster task completion.
Wow, 2.8 times faster.
Yeah, and a 34% cost reduction compared to those isolated single-agent models.
That's huge.
Because you are getting vastly superior speed and accuracy simply because of how the system is structured hierarchically.
Right. You mentioned the roles. You've got supervisor agents, domain agents, tool agents, and
Hundred agents, right?
audit agents, right? Let's break those down mechanistically. So in our microservices framework, or our kitchen, the supervisor agent acts as your API gateway and your load balancer combined.
Exactly. It takes the initial prompt from the user, but it doesn't do the heavy lifting.
It maintains the overarching context.
Correct. It keeps the big picture in mind and routes the specific subtasks to the domain agents.
And those domain agents, those are the line cooks, the specialized workers.
Yeah, they're usually smaller models that are fine-tuned for just one specific semantic area. So maybe you have a Python coding agent.
Or a legal contract analysis agent.
Or a financial forecasting agent, right. And because their scope is so narrow, their accuracy is remarkably high.
But they still need data to work with.
Always. Which is where the tool agents come into play. They are the connective tissue to your existing infrastructure.
Their whole job is just executing API calls, right?
Right. Querying your ERP system, pulling records from a SQL database, and then passing that structured data back up to the domain agent.
Okay, so that covers the speed and the execution. But hovering over all of this, like a health inspector in our kitchen, is the audit agent.
Yes, the audit agent.
And this is where we really bridge the gap between high-speed execution and the harsh reality of the EUA I Act.
Exactly. Because the audit agent isn't generating content. It isn't writing code or analyzing a contract.
What is it doing there?
Its entire computational purpose is to act as an internal compliance firewall. It checks the outputs of all the other agents against a predefined set of safety and regulatory rules before any action is finalized.
And having that audit agent is pretty much non-negotiable now, isn't it?
Totally non-negotiable. The EUA I Act is rolling out in phases, and Phase 1 is actively being enforced today. January 2026 was the start.
And the penalties aren't just a slap on the wrist.
No, the penalties for noncompliance are severe. We are talking up to 6% of global revenue.
6%. I mean, for a multinational corporation, that is a devastating financial blow.
It's billions of dollars in some cases. The legislation places intense scrutiny on anything that is deemed a high-risk system.
So what exactly makes an agent high risk?
Well, if your agents are touching creditworthiness assessments, for example,
Okay.
or hiring and recruitment pipelines, child safety protocols, basically anything that could impact someone's livelihood or safety, you are operating in the high-risk tier.
Yet, despite those massive stakes, the Capgemini survey data in our sources shows something terrifying. 62% of European enterprises currently report having readiness gaps for AI Act compliance.
It's alarming.
Over half the market is actively deploying autonomous systems without knowing if their underlying architecture actually meets the legal standard for transparency.
Which brings us to how CTOs are actually trying to solve this right now. Because you don't solve compliance by just writing a nice policy document for HR.
No, you have to solve it at the engineering level.
Exactly. Through what AetherLink calls safety, interpretability, and governance tools. Down in Eindhoven, we are seeing enterprise-grade systems utilizing very specific technical safeguards.
Like what? What's the first line of defense?
The first one is decision logging. But I want to be clear, this isn't just standard error logging where it spits out a 404 code.
Right.
This is semantic tracing. Every single time an agent passes a token or makes an API call or triggers an action, it is timestamped, cryptographically hashed, and securely stored.
So an auditor can basically look at the log and see the exact contextual breadcrumb trail.
Yes, they can see exactly how an agent arrived at a specific conclusion.
Which completely eliminates the whole black box problem.
Exactly. You aren't just presenting a final output to the compliance team. You are presenting the underlying mathematical logic that led to the output.
Okay, but what about when the agent is just unsure? To prevent these systems from making wild guesses, I know developers are hard-coding confidence thresholds into the orchestration layer.
Yes, the confidence threshold is a really critical safety valve. You see, every prediction an AI makes comes with a statistical probability.
Right.
So if a domain agent is reviewing, let's say, a loan application, and its confidence in rejecting that loan drops below, I don't know, 92%,
The system steps in.
the orchestration framework automatically halts the autonomous process. It packages all the context and escalates it to a human in the loop.
So the AI essentially knows what it doesn't know.
Precisely.
But when it does make a decision, it has to be able to justify it, which brings us to SHP values.
Oh, SHAP values. This is deep data science territory.
It is, but it's essential for everyone to understand. SHAP stands for Shapely Additive Explanations. Basically, instead of the system just saying loan rejected, SHAP values provide a mathematical breakdown of feature attribution.
It calculates exactly how much weight the model gave to different variables.
Right, so it outputs a matrix that says something like income level contributed 40% to this rejection, while credit history contributed 50%.
Exactly. It takes the invisible multidimensional math of a neural network.
Which nobody can read.
Right, and it translates it into a human-readable ledger. It is the ultimate tool for legal defensibility.
Because if an auditor claims your AI is biased,
You don't just shrug your shoulders. You pull the SHAP values and prove exactly which data points drove the model's behavior.
Okay, I'm going to push back here, though.
Go for it.
Just from the perspective of a developer or a business leader who is under immense pressure to deliver speed.
Sure.
We established earlier that multi-agent systems give you a 2.8x speed advantage. But if I have to run semantic decision logging on every single token, calculate these complex SHAP matrices for every output, and build infrastructure to halt and route low-confidence tasks to humans,
I see where you're going.
doesn't all that computational overhead completely throttle the system? It feels like we're taking a rocket engine and putting a massive governor on it.
That is the exact debate happening in boardrooms right now. And it fundamentally comes down to how you architect the system in the first place.
Okay, how so?
Well, if you try to bolt compliance tools onto an existing rigid framework as an afterthought, yes, the latency will kill your speed advantage.
It'll just drag it down.
But if you embed this governance natively into the orchestration layer using custom agentic frameworks like the ones developed by AetherLink's EtherDev team, the logging and interpretability actually happen asynchronously.
So it doesn't block the main execution thread.
Exactly. And furthermore, the speed you lose in, microseconds of compute time is absolutely dwarfed by the time you save by preventing catastrophic rollbacks.
Right, because unwinding a mistake is a nightmare.
If a high-speed agent makes a biased decision at scale, and you lack the governance to catch it early, the legal fees and the engineering hours spent unwinding that mess will completely erase any ROI you thought you gained.
That reframes the issue entirely. Basically, speed without steering just means you crash into the wall faster.
Perfectly said. Governance isn't a speed bump. It's the brakes that allow you to drive fast in the first place.
I love that. So, assuming a company gets the architecture and the governance right, let's look at the financial reality.
Let's do it.
Building a distributed, multi-agent framework with native compliance tools requires significant upfront capital. How do the economics actually justify that investment?
The financials are highly compelling, but they do require a shift in how CFOs view operational expenses.
Right.
We are no longer looking at minor software licensing fees. We're looking at replacing massive labor costs with compute costs.
The sources actually highlight a really concrete case study on this from the Brainport region.
Yeah, the logistics company.
Right, a logistics company that deployed multi-agent orchestration for their warehouse management system. Let's trace their baseline before AI. They were running a highly manual picking, packing, and routing process. That required 40 full-time employees, which cost them roughly 1.8 million euros in annual labor.
And on top of that, human error.
Yeah, misrouted packages, inventory discrepancies, that was costing them an estimated 180,000 euros a year. So their baseline operational burn was basically 2 million euros annually.
Right. Then they integrated the multi-agent workflow. Now, they didn't replace the physical warehouse workers doing the heavy lifting, but they completely automated the logistical routing, the inventory forecasting, and the compliance documentation.
So what happened to the staff?
They reduced the administrative and management staff from 40 down to just 8 human overseers.
Wow, from 40 to 8.
Yeah, and those 8 people now act as the human in the loop for those escalated confidence thresholds we just talked about.
That makes perfect sense. So what was the final cost?
The total cost for those 8 employees combined with the cloud infrastructure and the inference costs to actually run the agents, came to 320,000 euros annually.
That is a staggering reduction. You drop from a 2 million euro burn rate down to 320,000 euros.
It resulted in a year-one ROI of 156%, and the system paid for itself in just 3.2 months.
That's incredible.
But what makes this a real textbook case study for CTOs is what happened in year 2. They achieved what is known as superlinear ROI.
Superlinear ROI. I love that concept. It basically means that your financial returns don't scale linearly with your effort, right? They compound exponentially.
Exactly.
Think of it like building a digital nervous system, putting the brain and the spinal cord in place, the core supervisor agents, the audit logging, the API connections. That's incredibly hard and expensive.
Very expensive up front.
But once that core infrastructure exists, attaching a new limb is almost free.
Yes. When this logistics company scaled from 1 warehouse to 15, they didn't have to rebuild the governance framework or retrain the orchestration logic.
So the ROI jumped.
Their ROI jumped from 156% to 380%, because the marginal cost of deploying the next agent basically approaches zero.
That reuse of the foundational architecture is what drives those superlinear returns.
It is. However, capturing that margin requires meticulous management of your tech stack, specifically regarding inference costs.
Right. Let's define inference real quick.
Sure. Inference is the computational process where a trained AI model actually runs live data to generate a prediction or an output.
It's the engine actually running.
Exactly. And if you build your entire multi-agent system relying on massive general-purpose LLMs, large language models with hundreds of billions of parameters, your inference costs will bleed you dry.
It's the computational equivalent of using a sledgehammer to swat a fly.
It really is.
Because if you just need a domain agent to check a date format on an invoice, you absolutely do not need an API call to a trillion parameter model that was trained on the entire internet.
It's just economically inefficient.
Right.
Which is why the smartest enterprise architectures are pivoting heavily to SLMs, small language models.
How small are we talking?
Models with maybe 7 or 8 billion parameters.
Yeah.
They're small enough to run locally on a company's own on-premise servers.
And they can actually handle the work.
For highly specific, narrowly scoped domain tasks, an SLM performs just as well as a massive LLM. And by running these locally, manufacturing firms in Eindhoven are cutting their inference costs by 85%.
Wow.
85% compared to an API-first approach that pings external servers for every single token.
That 85% reduction in compute cost is what actually enables that superlinear ROI we talked about.
Absolutely.
But small models have a notoriously limited parametric memory. Because they haven't ingested the entire internet, they are highly prone to hallucinating if you ask them a question outside their narrow training data.
That is true.
So how do developers ground these SLMs so they don't just invent facts?
The mechanism they use is RAG, Retrieval Augmented Generation.
Yeah.
This is really the absolute cornerstone of enterprise AI right now.
Right, RAG.
Instead of relying on the model's internal memory, RAG fundamentally changes the workflow. When a user asks a question, the system first converts that query into mathematical vectors.
Yep.
Then it searches a company's proprietary vector database. It finds the exact internal documents, maybe the specific supply chain contracts or the internal compliance PDFs, and it feeds those documents directly to the AI as context.
So it essentially forces the AI into an open book test.
That's a great way to put it.
It basically says, hey, do not guess the answer based on your training data. Read these 3 specific paragraphs I just retrieved for you and generate your response based only on this text.
That's exactly how it functions.
Yeah.
And by utilizing RAG, you practically eliminate hallucinations. But more importantly, you create a legally defensible output.
Because the AI's response is mathematically tethered to your own approved corporate data?
Precisely.
Let's look at how all these architectural choices, SLMs, RAG, and multi-agent orchestration actually collide in a real-world scenario.
Let's do it.
The sources detail a pharmaceutical firm that spent 18 months analyzing different SDKs or software development kits to build their agentic workforce.
Right. An SDK provides the foundational code libraries and tools that dictate how easily your agents can integrate and scale.
And this firm needed to support 10 concurrent agents processing 500,000 queries a month.
So they ran a massive cost-benefit analysis on 3 different deployment strategies.
Let's walk through those.
Option 1 was the API-first approach, leaning entirely on proprietary massive LLMs hosted by third parties. Between the high inference costs and the constant data transfer, the operational cost came out to 380,000 euros.
which eats right into your margins.
Exactly. So option 2 is a hybrid approach that utilized small language models running locally, paired with a robust RAG pipeline to access their private data.
And the cost on
The
that.
cost plummeted to 140,000 euros. It was highly efficient.
But option 3 is where the strategic long-term thinking really comes in. They looked at deploying a fully custom agentic framework similar to what AetherDV builds, which cost 185,000 euros.
Now, the custom framework was slightly more expensive upfront than the hybrid model. That's because of the heavy engineering required to build native audit agents and decision logging.
Right, and the plumbing.
But the firm ultimately recommended the custom framework. Why? Because an off-the-shelf SDK doesn't give you the granular control over the context window routing or the deep interpretability required by the EUA I Act.
You're stuck with their rules.
Exactly. The custom framework provided the exact governance tooling needed for legal compliance while still keeping marginal costs incredibly low for future scaling.
It proves that selecting your architecture isn't just an IT decision anymore. It dictates your compliance, your speed, and your profit margins all at once.
It really is the ultimate business decision.
We have covered an immense amount of technical and strategic ground today. We've mapped the shift from brittle solo models to the distributed power of multi-agent microservices.
We covered a lot, yeah.
We've looked at the harsh realities of the EUA I Act and how tools like SHAP values and decision logging turn the black box into a transparent ledger. And we've seen how small language models paired with RAG deliver that massive 85% reduction in compute costs. As we wrap up this deep dive, what is your ultimate takeaway for the developers and CTOs navigating this space?
My core takeaway is that your orchestration architecture is your new competitive moat. Having a slightly smarter AI model than your competitor just doesn't matter anymore. The models themselves are commoditized.
Right.
What matters is the system. A well-designed multi-agent hierarchy that inherently understands context routing, paired with native audit agents that ensure absolute regulatory compliance, is what enables strategic differentiation.
It's the whole kitchen, not just one cook.
Exactly. It allows you to deploy automation at a scale your competitors simply cannot match without risking massive fines.
I think that is spot on. And my number one takeaway builds directly on the financial side of that architecture, the reality of superlinear ROI.
Yeah, that's a big one.
For anyone listening who is tasked with building this, the most grueling, expensive, and frustrating part of your journey will be deploying that very first agent, building the vector databases for RAG, establishing the security protocols, setting up the decision logging it, is a heavy lift.
It's not easy.
But you have to view it as building the central nervous system. Once that foundation is poured, adding the 5th, the 10th, or the 50th workflow compounds your returns exponentially.
It's all about laying the groundwork now for what's coming next. And I actually want to leave everyone with a final thought to consider, because the timeline is moving faster than most realize.
What are you thinking?
Well, today, in 2026, we are focused entirely on orchestrating agents within the boundaries of our own companies. We are controlling our own internal microservices.
Right.
But look ahead to 2027. What happens when your company's highly autonomous procurement agent starts negotiating directly with a vendor's highly autonomous sales agent via API? When multi-agent systems from completely different corporate entities begin transacting with each other, human logic and human pacing are completely bypassed.
That's entirely machine to machine.
Exactly. It opens up a massive question. How do you audit, govern, and trust a machine-to-machine negotiation that executes a binding contract in a millisecond?
That is an absolutely fascinating and wildly complex frontier that completely redefines B2B commerce.
It changes everything.
We will definitely have to tackle the architecture of machine-to-machine transactions in a future deep dive. For more AI insights, visit etherlink.ai.